Hello everyone, this is lecture 4 and of metric space unit 3. Now we'll see an example. What's that example is that let x comma d and y comma d start with two metric space. F and g are two continuous function on x onto into y. Suppose this is the metric space x comma d and we have another metric space y comma d start with two metric space, and there are two continuous function f is and g. So what is the collection of this set? Collection of those x where they are taking the same value. So let A is the collection of all x belongs to x such that fx equal to gx. Need to prove that f each claim kara korbo ache mote claim h closed in x. It is sufficient to show that a complement is open in x. Case 1, if a complement is phi is open in x, every set is open in x, implies a complement is open. If case 2, if a complement is not equal to empty, not phi, non-phi. Now again I have already discussed that how to show that a set is open or not. To show that a set is open, it is sufficient to show that every point is an interior point. For that we take just now what the proof korba a complement is open. So this is a complement. So I will take a point x in a complement and I will show that there exists a neighborhood of x which contain in a complement. Let a belongs to a complement. We need to find a neighborhood of a which contained in a complement. A belongs to a complement means what? A does not belongs to a. What's the set A is all about? The collection of all x such that fx equal to gx. So the 8 in a 9 now, that meaning kana haba f of a ta pakka not equal to g of a, right? F of a and g of a duita kino ochon y comma dy re, implies the d star between f a and g of a is strictly greater than 0. They are not equal by the definition of metric space. So let epsilon, I choose epsilon is nothing but the distance between fa and ga. Now I will use the condition that f and g are means continuous. Since f and g are continuous on what? X. That implies for say epsilon and bhari, for epsilon positive, this is positive, right? There exists a delta such that the star between fx and fa is less than epsilon by 3. Because of the continuity definition, for all epsilon there exists a delta such that this distance between fx and fa is less than epsilon by 3 whenever x belongs to, or distance between whenever the distance between x and a is less than delta. Same for g, distance between gx and ga is less than epsilon by 3 whenever distance between x and n is less than delta. Now the next last thing, the distance between fa and ga. देखो fa and ga टा किन होचे आमर? We have 2 point a and b. fa दुटा function होचे f and g. तो fa टा भी इन्हें belong करतोबा, ga टा भी किन belong करतोबा y रे. So the distance between fa and ga by the triangle inequality, I can say that this is less than equal to distance between fa and fx plus distance between fx and gx plus distance between gx and ga as a law of triangle inequality. Now distance between fa and fx, we just let it show distance between fa and fx is less than epsilon by 3, distance between gx and ga is less than epsilon by 3. And what is the distance between fa and ga? We have taken that is distance between fa and ga is nothing but we have taken this is epsilon. This one is less than epsilon by 3 plus distance between fx and gx plus कितने epsilon by 3, epsilon by 3, epsilon by 2, epsilon by 3. इन कैसे को लेकर आबा 0 is less than epsilon by 3 is strictly less than equal to distance between fx and gx. So means distance between fx and gx is strictly positive. No, wait. This is true for all x belongs to s of a delta. जेबे distance between x and a टा less than delta ले ई जिनिसटा होचे ना epsilon by 3 तो कना हला hence distance between fx and gx is greater than 0 for all x belongs to s of a delta. Implies distance between fx and gx is greater than 0. पक्का fx टा not equal to gx for all x belongs to s of a delta. तो जेहेतु fx and gx ର distance ଟା greater than 0 है means they are not equal. जो equal है distance 0 है and that is true for all x belongs to this. तो fx is not equal to gx for all x belongs to this. और कि नहीं? That implies what? X belongs to a complement because they are not equal ना. What is the a is all about? A is all about the collection of all x such that fx equal to gx. But we have that fx is not equal to gx. Implies what? X belongs to a complement for all x belongs to what? S of a delta. जेबे x टा e neighborhood रे होचे fx x टा किने belong करछे a complement. Implies what? x टा किन होचे जेबे x टा इनके belong करछे x टा a complement रे belong करछे तो x टा काहार भितरे होचे if x belongs to this implies x टा belong to किनो जीवा a complement रे belong करी नमा जेबे x टा इने होचे x belongs to a किनो होचे a complement. That means if x टा जदि इने होचे तो x टा किनो belong होबा a complement. तो s of a delta काहार भितर होबा a complement रे. So I have found a neighborhood of a because I have taken a point. तो the क्या proof करा था a complement is open. I have taken a point a complement but neighborhood खोज में a रो ये काहार भितर थी बा a complement रो. So देखो जेबे x टा इने belong करछे x टा किने belong करछे a complement रे. That implies this one is a subset of a complement. So we have a neighborhood of a which containing a complement. Implies a complement is open. Implies a is closed. Same example आमे गुडे example एमते लिखे पारमा. Collection of all x belongs to x such that fx is not equal to gx is open in x. Okay, so the next lecture we'll see what is the extension theorem and related properties. Thank you.